Now, our specific objectives. Number 1, by the end of the lesson, students will be able to use a diagram to describe total internal reflection through triangular prism of 90 and 180 degrees. Secondly, you explain the necessary steps needed to find the refractive index of a triangular prism. Thirdly, you'll be able to state the factors in which the angle of deviation depends on. Fourthly, you'll be able to trace light rays through a triangular prism and obtain graphically the value of angle of minimum deviation. And finally, you'll be able to solve simple problems on refraction of light through triangular prism. Now, remember in our previous class we've talked about refraction of light through rectangular prism. Now today we are talking about triangular prism. Now a block with a triangular cross section is called a triangular prism. So from this diagram you can see a triangular prism. This triangular prism is a glass block that is triangular in shape, and it is an equilateral triangle. That is a triangle which all the angles are equal. So here we have this angle here, AB is 60 degrees. Here is also 60 degrees. And here is also 60 degrees, making it 180 degrees. So that is an equilateral triangle. Now recall that when light rays passes through rectangular glass block, the incident and emergent ray is displaced to one side. Remember, we've talked about the rectangular prism, whereby the ray of light can move from air, incident ray from air, on entering the glass prism, which is a rectangular prism, it will be refracted. Then from there, it will emerge. So, but there is no deviation or change in the direction of that emergent ray when compared with the incident ray. That is for triangular prism. That is for rectangular prism. So when we talk about rectangular prism, we did not say anything about deviated ray or angle of deviation. Now from this above diagram, a ray PQ is incident on the prism side AB. Now the incident, the refracted and the emergent ray are shown in a diagram. Now let's look at this diagram again. From this diagram you have triangle ABC, which is your equilateral triangle. Now you have this ray from the diagram PQ. Now you have your normal from the diagram, a straight line N1, N2. That is your normal, a straight line of angle 90 degrees. Now this is your incident ray PQ. Now on getting to this triangular glass, it will be refracted along QR. Now from here the ray emerges along RS. Now looking at this diagram, you find out that we have two angle of refraction. Now remember, angle of incidence is the angle which the incident ray makes with the normal. And here our incident ray is what? PQ. And look at the normal. So this is my angle of incidence, I. Then we equally have our angle of refraction. Look at my refracted ray, QR. And the angle which the refracted ray makes with the normal, look at the normal, is angle of refraction. So here we have two angle of refraction, which we call R1. This is another normal. Now we have another angle here, R2. Now this is my emergent ray, RS. Now the angle of emergent is the angle which the emergent ray makes with the normal. And look at this normal here, N2, N3, N2. So look at the emergent ray. Now an interesting thing occurs here. You find out that here, look at the incident ray. On getting here, the incident ray deviated. Instead of moving straight, it deviated here. So when you trace this angle of this incident ray straight and you trace the emergent ray in a straight line. Where these two rays meet, you have your angle of deviation. Where the incident ray and the emergent ray, where they meet, is where we have our angle of what? Deviation. That is where we have our angle of deviation. Now this angle A is called the refracting angle of this prism. So the angle A is the angle from the prism side AB and side AC. We call it the refracting angle. And this refracting angle is always 60 degrees. Now from geometry, you find out that R1 plus R2 will be equals to 2A. That is R1 plus R2 will give you what? 60 degrees. So R1 plus R2 will give you 60 degrees. We are going to apply that later. That is R1 plus R1 will give you A. So when you add these two angles, this R1 plus this R2, it will be equals to A, which is the refracting angle. We are going to see that later. Now, from here, we are going to see, let's look at this. We have explained this. We've talked about the angle of deviation. Now, this angle of deviation is the angle between the incident ray and the emergent ray of light passing through the prism, as I have said. Now, the amount of deviation is determined by, there are factors that determine the amount of deviation we are going to obtain. And what are they? Number one factor is the angle of incidence. Number one is the angle of incidence I. Then number two is the refracting angle of the prism, which we call capital letter A. And number three is the refractive index of the prism. The refractive index of the prism. They used to ask this in WAEC. State 2 factors or state 3 factors in which the amount of deviation depends on. So what are these factors? Number one, the angle of incidence I. Number two, the refracting angle of the prism A. And number three is the refractive index of the prism. Number three is the refractive index of the prism. Now, we define the refracting angle of the prism as the angle between the refracting faces AB and what? AC, as I've shown you in the diagram. Now, we are going to look at an experiment to find the refractive index of a triangular prism. Experiment to find the refractive index of a triangular prism. Remember, we did the same thing in a rectangular prism. Now, what are the things we need? You need your softboard, your tracing paper, you need optical pins, then you need your triangular glass block. Now, from this diagram, how do we do that? First of all, you trace out the triangular prism in your tracing paper and label the side, as you can see here, ABC. Now, you draw a normal, which is a straight line of angle 90 degrees. Then you measure a particular angle of incidence. We can say 20 degrees. You measure angle incidence 20 degrees. Then you place two optical pins at these points. We label P1 and P2. Now you replace the triangular prism. Use two other optical pins as we label here P3, P4. View it from the side of this prism AC. Put these two pins P3 and P4 to be in a straight line with the images of the pins P1 and P2. Now once you view it through the side of this prism AC and pin P3 and P4 are in a straight line with the images of P1 and P2, you can remove the pins and join P3, P4 using a straight line. Then remove your prism and equally you draw a normal. Then you join this ray also. Join this straight line EF. Now from here you can measure your angle of incidence using your protractor, that is angle I, which already we have measured. Now you can equally use your protractor and measure your angle of refraction, which is R. Then from here equally you can measure the angle of emergence, which we call E. Now another angle we can measure here is our angle of deviation. Use your ruler to trace up the incident ray and trace up the emergent ray. Where these two rays meet, as we have said before, use your protractor and measure this angle. And that is the angle of what? Deviation. Now, when you have done that, you find out that the angle of I and R are indicated in the ratio of, with our formula using the Snell's law, that N is equals to sine I over sine R. So using our Snell's law, your sine I and sine R will give you the refractive index. Now also, if we measure the deviation produced for different angle of incidence, as I've said, then we can plot a graph of angle of deviation D against angle of incidence I, and we will obtain a graph as you can see here. So from the experiments, when we record or we measure the sine of angle of incidence with the sine of angle of refraction, it will give us our refractive index N. The same thing we did in our rectangular glass block. But in this case, also in this triangular prism, we find out that as we measure the angle of deviation and plot a graph of D against I, we have an interesting observation. Now, we plot our D, angle of deviation, in y-axis, that is vertical, and our angle of incidence in s-axis, that is horizontal. You find out that you have a graph that is curved, a curved graph. And here you find out that as the angle of deviation decreases, the angle of incidence increases. So as the angle of incidence is increasing, the angle of deviation is decreasing, until at a particular point where the deviation is least, we call it minimum deviation. At this point, you find out that as the angle of incidence increases now, angle of deviation will continue to increase. So where the deviation is least, we obtain what we call minimum deviation, and we represent it with capital letter D. So from this graph, as I've said, angle of minimum deviation occurs when the incident and emergent rays are equally inclined to their respective surface. Now the ray, they pass symmetrically through the prism, and the angle of incident will be equal to angle of what? Emergent. So at minimum deviation, you find out that this ray, they passes symmetrically through the prism, and at this minimum deviation, angle of incidence is always equal to angle of what? Emergent. Is equal to angle of emergent. Now, with experiments, we find out that there is a formula that will connect the minimum deviation, the refractive index of glass, and the refracting angle of the prism. What is this formula? The formula is related as refractive index N is equals to sine. The refractive index N is equals to sine half brackets A plus D, bracket closes, all over sine half of A. Remember your N the refractive index. Your A is the refracting angle of the prism, which is always 60 degrees. Then your D is angle of what? Minimum deviation. Now the graph of the above experiment shows that as the angle of incidence increases, as I've said, that the angle of deviation decreases until at a certain minimum value, where the angle of deviation begins to increase for further increase in the angle of what? Incidence. Now the graph is thus a curve. We have seen that. Now if the angle of incidence on the face AB of the prism is such that the refracted ray NM meets the face AC at an angle for air glass interface about 42 degrees, we find out that the light will be what? Totally internally reflected, and the light will emerge from BC of the prism. We have talked about total internal reflection, whereby we saw the critical angle for glass to be 42. So when this angle is greater than 42, we find out that the ray will be what? Totally internally what? Reflected. Now, we are going to end with one example and continue in our next class. Example 1. A ray of light experiences a minimum deviation when passing symmetrically through an equilateral triangular prism. Calculate the angle of incidence of the ray. Now, you are given the refractive index of glass to be what? 1.5. Now, we are given the refractive index of the glass to be 1.5, and we are meant to calculate the angle of what? Incidence. Now you draw the equilateral triangle as we have said. Now look at your incident ray. The incident ray. Then you have your normal. Look at your normal. The incident ray. This is the incident ray. This is the normal. NP. This ray on entering the glass prism will be refracted. Now then the ray will also be emerge. So here you have two refracted rays, as I told you before, R1, R2. And remember I told you that this R plus R will give you what? A. Geometrically 2R will be equals to A, and A is the refracting angle of the prism. Now mathematically you find out that, remember we said that when ray passes symmetrically through the prism, that angle of incidence I will be equals to angle of what? Emergence. And also R1 will be equals to R2, and that is equals to R. That is the angle of refraction in the glass. Now also when this ray passes symmetrically, you find out that PR, which is the refracted ray, is parallel to the base of the prism when the ray passes symmetrically. PR is parallel to the base, which is BC. Now look at this diagram. This PR, we consider this as a straight line now, is parallel to this line BC. So look at, here is B and here is C. So PR is parallel to what? BC. Now, as a result of that, you find out that you say that PR is parallel to BC. Now, angle BPR. Angle BPR, we have our B here, our P, and our R. So this angle here, that is angle BPR. The whole angle here, from here to here. Remember, angle on a straight line is how many? 180 degrees. So if you want to find angle BPR, that is from here to here, it will be 180 minus 60, and that will give me what? 120. So angle BPR from here to here, BPR will give me how many? Will give me 120. Now, also take note that NPQ is normal to AB. Look at your N, your P, and your Q is normal. That is straight line of what? 90 degrees. Now hence, how do I find my R1? R1 will now be what? 120, which is the whole of this angle from here to here, 120, minus the angle from here to here, which is 90. that will give me my R1. So 120 minus 90 will give me R. So my R, which is angle of refraction, is equals to 30 degrees. But I told you you can equally solve it the other way around using method of geometry of the prism, where we say that R plus R is equals to R. That means R plus R, which is 2R, is equals to the refracting angle, which is 60. So solving it with geometry of the prism, you find out that 2R is also equals to A. We are trying to obtain our R. So if 2R is equals to A, which is 60, that means my R is also what? 30 degrees. So any of the method we can use to solve it. Remember what we are looking for. We are looking for what? We are meant to calculate the angle of incidence of the ray. Now we are going to use our Snell's law, where we have that sine I over sine R is equals to N. Now sine I is what we are looking for. All over sine R, we have gotten out to be 30. That is sine 30 is equals to N. From the question, we were giving N to be 1.5. Now sine I will do cross multiplication. It will be equals to 1.5 times sine 30. Remember, sine 30 is 0.5. When we multiply that, we have 0.75. Now that is sine I, but we are meant to find I. So how do you find I? I will be what? Sine inverse of 0.75. In your calculator, you press shift, you press sine. It will give you the sine inverse. And the sine inverse of 0.75 will give us how many? It will give us 48.6 degrees. So our angle of incidence here is 48.6 degrees. In our next class, we are going to continue by solving other examples. Thank you for your patient listening. I remain your teacher, Mrs. Okuma. Bye.